We've all seen plasma effects on Warhammer and other minis, but what if we could make them actually glow? My name's Mark, I'm an engineer, and we're going to use fluorescent paint, phosphorescent pigments, and UV light to make plasma effects that glow. That really glow, even in the dark. This is what we're going to use to get our phosphorescent effect. Glow-in-the-dark pigment purchased from Amazon. According to the internet, some kinds of phosphorescent pigment can be damaged by water. An easy way to test is to get a little wet, then smell it. If it's breaking down, it will give off an ammonia odor. Don't detect anything on it. Now let's see if it still glows. And we do get quite a bit of glow out of it. Now I've already tested this powder, and it is compatible with water. If it wasn't compatible with water, we'd have to switch from, say, an acrylic paint to an enamel, or from a PVA glue to super glue. Glow-in-the-dark pigment uses phosphorescence. This is how that works. So in phosphorescence, the material gets hit by a photon, piece of light coming in, an electron absorbs it, the electron jumps up to its next highest orbit level, and it immediately wants to drop back down. But the way the phosphorescent material works is there's something in there called a trap that keeps it from going down. It gets stuck there until it absorbs enough heat from the ambient environment to get out of the trap and drop down. And when that happens, it shoots out a photon. Without this trap, the material would absorb and re-emit the photons immediately. But with the trap, because it's got to absorb heat over time, it does it slowly, and that's what gives us our glow. Now we need to fix the pigment to the model. I tried mixing it with matte medium and clear varnish, gluing it with PVA and super glue, but what I found worked the best was painting the detail we want, then sprinkling the pigment on. The matte medium and varnish didn't have enough pigment, and the glue tended to either obscure the details or go everywhere. You can use any color paint you wish. Since the pigment I'm using is white, I chose a heavy-bodied artist acrylic. Let that dry, shake off the excess. Let's compare a typical blue one would use in a conventional non-glowing plasma effect to two fluorescent paints. We'll look at Ammo Cyan, Army Painter Plasma Coil Glow, and Green Stuff World Fluorescent Blue. In conventional light, they all look very similar. But under UV light, the differences become obvious. We can see that the regular paint doesn't glow at all. The Army Painter glows quite a bit. And the Green Stuff World glows a little bit. Fluorescence. It's the same process, except it's missing the trap. So as the photon comes in, it gets absorbed, kicks the electron up, the electron drops right back down and kicks out a photon. Except this photon is not the same color as this one. The color of light is determined by how much energy the photon has. Violet's the highest, red is the lowest, and everything else is in between. So that tells us we can absorb a photon of, say, blue light, and we can emit anything at a lower level. But you can't go backwards. You can't absorb a photon of orange light and emit violet. So this tells us one thing. Our light should be in the violet range, and that's typically what we use is a UV light to illuminate and make the glow. Another thing that's important to consider is the human eye. And the human eye is not sensitive the same way to all colors. It's more sensitive to green than it is to blue or red. So that makes this color and this color hard to produce. This one, because we're not very sensitive to it, so we have to shoot out a lot more photons to see it. And this one, for two reasons. We're not sensitive to it, and it requires very high energy photons. So based on the energy required for each different color of light and the sensitivity of our eye, this is kind of the sweet spot of colors we're going to look at for our glow effect. Violet and red are the most difficult, so we're going to kind of leave those out. Blue and green are pretty easy, and yellow and orange are the next. We are using the Army Painter Plasma Coil Glow to paint the recesses. There are two common approaches to this effect, either having the brightest part on the outer parts of the coil or the brightest part on the recesses. I'm going with the outer parts being brightest, with the darker colored parts in the recesses for the important reason of it's easier. Here's a quick look at the finished effect on the bench. Now when you're doing this, you probably want to do it as a separate step and change your wash water when you're done, because you could be getting glow all over the place. Here's a glow comparison of all the pigments in the set. As expected, the violet and dark blue are the dimmest, and the rose red isn't very bright either. Next, I'll look at object source lighting. and how we can amp that effect up.